Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2024 10A Problem 14 and it deals with geometry. I hope you guys enjoyed this video and let's get started. The problem states one side of an equilateral triangle of height 24 lies on line L. A circle of radius 12 is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and line L can be written as a times square root of b minus c pi, where a, b, and c are positive integers and b is not divisible by the square of any prime. What is a plus b plus c? So here we see that we have a diagram, and this is from this person, and you can look this up at artofproblemsolving.com. And I'm just going to use their diagram because it's a lot more clearer, and they've already shaded in the area that we're trying to find, which is the yellow shaded part. So I labeled the three vertices of the triangle A, B, and C, and then the points of tangency D and E, and then the center of the circle O. So if we want to find out the shaded area, that means I'm going to connect O with D and E. And now we have a circular arc, and then the shaded area that we're trying to solve for. So my thought process is I'm going to split this in half, connecting it with C. Now we see that we have two triangles, ODC and OCE. Now, if we find out the combined area of these two triangles, we can subtract the whole area minus the area of the arc to get the remaining shaded yellow part region. So to do that, we need to find out some angles. Well, we know that these two are 90 degrees. And then since this is an equilateral triangle, that means that this angle is 60. And therefore, this angle right here is 120. Knowing that that is 120, and then we have these two angles which are 90 degrees, ODC and OEC, the sum of the angles in an equilateral and a quadrilateral is 360. So that means 360 minus 120 minus 180 gives us 60. So that means that this whole angle right here, the angle of the arc, is 60 degrees. And then keep in mind we split it in half, so each of these would be 30. And then we know that if this is 30, this is 90, then triangle ODC and OEC, these are 30, 60, 90 degrees triangles. I'm just going to draw them out right here real quick. Okay, so we can just find out the area of each triangle, or one triangle, and then multiply by 2 to get the combined area. Well, we know that OD, this is 12. That's the radius. So that's 12. Utilizing the 30, 60, 90 triangle rules, we get that DE is 4 times square root of 3. We simply just divided 12 by the square root of 3. And so now we have the base, which is 4 times square root of 3, and the height, which is 12. So 4 times the square root of 3 times 12 divided by 2. That is the area of one triangle. But then we're going to multiply by 2, so I'm just not going to divide it at all because it'll just cancel out. So the combined area of the two triangles are 4 times the square root of 3 times 12. And that's the whole area. Now we want to subtract the area of the arc from the total area. Well, we already got that the angle of the arc is 60 degrees. So that's 60 over 360 times the area of the whole circle, which is pi r squared. R in this case, the radius is 12, so 12 squared. So it'd be 16 times 144 pi And these would cancel out to get 24. So it'd be 24 pi is the area of the arc. So we subtract 24 pi. And then we can multiply this out to get 48 times the square root of 3 minus 24 pi. And now we can just add it up, because it's asking for a plus b plus c. So it'd be 48 plus 3 plus 24 to get 75. So our answer is D, 75.